Creating physical objects is a fundamental human endeavor. From tools to toys to sculptures, acts of creation allow us to find meaning and improve our quality of life. We've even named entire eras of our history after common materials, from the Stone Age to the Bronze Age to the Iron Age and beyond. Today, we find ourselves on the dizzying crest of rapid technological development. We face unprecedented and existential challenges, such as anthropogenic climate change, but we also have more tools and materials than ever before to tackle these challenges. One of the most recent advances in our ability to engineer materials is the process of 3D printing, which allows us to create complex, computer-designed structures one layer at a time. Imagine a sculptor who chips away at a block of marble to remove material where they don't want it. 3D printing flips this around by only adding material where we do want it. Often, this allows us to make things more quickly and with less waste. Or we can flex our imaginations to realize previously impossible designs. A remaining challenge in the field is how to 3D print metals with very small features. The best existing methods use a laser to melt and solidify metal powders. However, this doesn't work well for some materials like copper, which transmit heat so well that even if you have a finely focused laser, the heat spreads out and melts too much powder, reducing the resolution. To overcome this challenge, we had to invent a new way to 3D print metals, and we knew that we couldn't rely on heat to define the part shape. Instead, we use ultraviolet light to join together molecular building blocks called monomers into a loose network called a hydrogel. We then convert this hydrogel into metal by infusing precursors and then taking advantage of chemical reactions like combustion and reduction. With this technique, we can 3D print copper with feature sizes about half the width of a human hair, much smaller than previously possible. And by studying these improbable transformations, we learned how to apply the paradigm of infusion and reaction to make lots of new materials, from battery electrodes to multi-component alloys, all with exquisite resolution. We hope to use these materials to solve societal problems, from making more robust batteries to lighter structural materials. We also hope that other researchers will take advantage of the tools we've developed to make their own new materials and follow their own journeys of innovation and discovery. Beyond 3D printing, each one of us has tools we can use to make the world a better place. What are your tools, and what will you make? Thank you.